Somewhere in the quiet darkness between galaxies, there drifts a delicate spiral of stars, a world island of suns, suspended in the vast cosmic ocean. We call it Messier 33, the Triangulum galaxy. Just 3 million light-years from our pale blue dot, M33 glimmers like a distant lantern. It is the third largest member of our local group, a younger sibling to the Milky Way and Andromeda, yet no less wondrous. M33 spans about 60,000 light-years, a swirl of 40 billion stars, each one a sun, each one a potential cradle for worlds and stories we can only imagine. Unlike our own galaxy, whose structure we must infer from within, M33 presents itself openly, a cosmic pinwheel turned toward us, inviting our curiosity. Its spiral arms are loose, patchy, flocculent, not the grand sweeping arcs of Andromeda. They shimmer with young blue stars, the luminous children of cosmic nurseries. In the heart of M33's arms lies a furnace of creation, a nebula so vast, so radiant, that even across millions of light-years, its light reaches us. This is NGC 604, one of the largest star-forming regions in the entire local group. It stretches 1,300 light-years across, a cathedral of gas and dust, illuminated by hundreds of massive, short-lived stars. In M33, star formation is not a quiet process. It is exuberant, vigorous, a celebration of cosmic chemistry. Galaxies are not merely collections of stars. They are ecosystems, vast, evolving, interconnected. M33 contains enormous clouds of hydrogen, the raw material of stars, molecular complexes where gravity sculpts new suns, low metallicity, echoing conditions of the early universe, relatively little dust, allowing us to peer deep into its structure. It is a natural laboratory for understanding how galaxies grow and change. But when we measure the rotation of M33, we find a mystery. The stars move too quickly to be held by the gravity of what we can see. Something unseen, something vast must be there. Like most galaxies, M33 is wrapped in a halo of dark matter, a silent, invisible scaffold shape-shaping its destiny. Galaxies, like stars, have relationships. They dance, they interact, they reshape one another across eons. M33 is likely a satellite of the Andromeda galaxy. Their past encounters may have stirred M33's gas, triggering waves of star formation that still blaze today. In the far future, as Andromeda and the Milky Way merge, M33 may join the cosmic embrace, 3 galaxies becoming one. Most large galaxies harbor a supermassive black hole, a gravitational titan anchoring the core. But M33 seems to be an exception. Astronomers find no evidence of a central black hole of significant size. If one exists, it is far smaller than expected. This challenges our understanding of how galaxies and black holes co-evolve. Because it is close, because it is open to us, M33 is a gift, a cosmic Rosetta Stone. It helps us study how spiral galaxies form, how stars are born in low metallicity environments, how dark matter shapes galactic disks, how galaxies interact within groups, and how stellar populations evolve over billions of years. When we gaze at M33, we are looking not merely at a distant galaxy, but at a chapter in the story of cosmic evolution, a reminder that the universe is vast, ancient, and filled with wonders beyond the reach of our brief lives, yet close enough for our minds to touch. We are a way for the cosmos to know itself, and in the soft glow of the Triangulum galaxy, the universe whispers back. The galaxy gets its name from the constellation Triangulum, where it can be spotted. It is sometimes informally referred to as the Pinwheel galaxy by some astronomy references, in some computerized telescope software, and in some public outreach websites. However, the Simbad Astronomical Database, a professional database, gathers formal designations for astronomical objects and indicates that Pinwheel galaxy refers to Messier 101, which several amateur astronomy resources, including public outreach websites, identify by that name, and that is within the bounds of Ursa Major. The Triangulum galaxy is the third largest member of the local group of galaxies. It has a diameter measured through the D25 standard, the isotope where the surface brightness of the galaxy reaches 25 mag/arcsec squared, to be about 18.74 kiloparsecs, 61,100 light-years, making it roughly 70% the size of the Milky Way. It may be a gravitationally bound companion of the Andromeda galaxy. Triangulum may be home to 40 billion stars, compared to 400 billion for the Milky Way and 1 trillion for Andromeda. The disk of Triangulum has an estimated mass of 3 to 6 billion solar masses, while the gas component is about 3.2 billion solar masses. Thus, the combined mass of all baryonic matter in the galaxy may be 10 billion solar masses. The contribution of the dark matter component out to a radius of 55 times 103 light-years, 17 kpc, is equivalent to about 50 billion solar masses. This galaxy has an inclination of 54 degrees to the line of sight from Earth, allowing the structure to be examined without significant obstruction by gas and dust. The disk of the Triangulum galaxy appears warped out to a radius of about 8 kpc. There may be a halo surrounding the galaxy, but there is no bulge at the nucleus. This is an isolated galaxy and there are no indications of recent mergers or interactions with other galaxies, and it lacks the dwarf spheroidals or tidal tails associated with the Milky Way. Triangulum is classified as unbarred, but an analysis of the galaxy's shape shows what may be a weak bar-like structure about the galactic nucleus. The radial extent of this structure is about 0.8 kpc. The nucleus of this galaxy is an H2 region, and it contains an ultraluminous X-ray source with an emission of 1.2 times 10 to the 39 ergs-1, which is the most luminous source of X-rays in the local group of galaxies. This source is modulated by 20% over a 10 to the 6 day cycle. However, the nucleus does not appear to contain a supermassive black hole, as a best fit value of 0 mass and an upper limit of 1,500 m solar is placed on the mass of a central black hole based on models and the Hubble Space Telescope data. This is significantly lower than the mass expected from the velocity dispersion of the nucleus, and far below any mass predicted from the disk kinematics. This may suggest that supermassive black holes are associated only with galaxy bulges instead of with their disks. Assuming that the upper limit of the central black hole is correct, it would be rather an intermediate mass black hole. The inner part of the galaxy has 2 luminous spiral arms, along with multiple spurs that connect the inner to the outer spiral features. The main arms are designated IN, north, and IS, south. So, while M33 might play third fiddle to the Milky Way and Andromeda in size, its furious starbirth and cosmic future prove that it is anything but ordinary. In a few billion years, it will join our galactic neighborhood in a massive cosmic merger. But for now, it remains a stunning, swirling jewel in our night sky, waiting for you to point your telescope or binoculars toward the constellation Triangulum. If you enjoyed this journey across 2.7 million light-years, hit that like button, subscribe for more deep space exploration, and let me know in the comments, have you ever spotted M33 in your own backyard? Thanks for watching, and keep looking up.